Thank you for having me today. It's really an honor to be here. I was working at KDI a while ago, so I really happy to meet old colleagues. I really respect them. I like them and their research. So today I'm going to talk about demographic changes, economic growth, and fiscal rules in a general equilibrium model of OLG. It's really long title. I'm sorry about that. So I couldn't drop any word from this title because I like all of them: demographic changes, economic growth, and fiscal rules. The fiscal rules is its main word in this title, in this paper. This is co-work with Dongwon Lee, who's a professor at Seoul University. I want to talk about this. This is when I submitted this paper to this conference, I didn't anticipate this paper would be published in a journal, but finally that was published in a Korean journal. So I extend this paper a little bit. This is what I had to do for this conference. Let me start with the introduction. Sustainable public finances will matter. This is because we have a conference today. So fiscal rules have been a major issue since we observed the Europe's debt crisis and fiscal cliff of the United States. When you look at the statistics Korea projections, according to the existing fiscal projections, the debt to GDP ratio is expected to be higher than 100% in 2050. Last month I was presenting this paper in Japan. The Japanese guys is laughing at 100% in 2050 is really small. It's compared to their number, it's more than 200%. We could consider fiscal rules to achieve medium and long-term fiscal soundness. I want to say this. Our paper didn't look at a short-run dynamics or business cycles or fiscal rule of the business cycle. We just look at the long-term impacts. So it's not quite conventional, but I want to understand the scope of this paper. So in our paper, we don't have any money. So we didn't look at the business cycles. That's why we didn't look at the money, monetary facts. Just look at the real side of the economy. The fiscal rules, let me introduce fiscal rules. Fiscal rules impose a long-lasting constraint on fiscal policy through numerical limits on budgetary aggregates like a debt to GDP ratio or primary budget balance, something like that. In this paper, we'll look at three different rules. First one is that rule is a rule that sets an explicit limit for public debt as percentage of GDP. A second rule of budget balance rule is literally a balanced budget. A third one is a hybrid rule. We call this hybrid rule. It's one that allows the debt to GDP ratio to be 60% by 2050. Why 60%? I don't know. We like that number. 60% is manageable by 2050. Many people many people working on public finance, they say 60%, less than 60% will be safe. I don't know, but just we choose that number. 100% we thought that was crazy, but 60% is reasonable in the long run, even though in the long run we owe that. So we call that that rule, that's benchmark rule or benchmark model. We call that benchmark model. So it's fiscal rule. It's compared with the benchmark rule because we need a reference point. So it is assumed that its fiscal rules should be implemented by 2050, and after that year, 2050, replaced with the benchmark rule. So it should be debt to GDP ratio should be constant after 2050. So in this paper, general equilibrium model of OLG built up. So we incorporate the changes in demographics and a low growth rate, TFP and workforce. Yeah, let me introduce the model. This is conventional OS model. I'm going to save my time. Spend 5 minutes. Okay. We assume the following four variables. Not three. It's four variables exogenously determine future government expenditures. We set this path given exogenously labor augmented technological growth and demographic changes, mortality rates, and birth rates. We calibrate from statistics Korea projections and interest rate. Okay, so we focus on government revenue. So only income tax rate is changing over time. Okay. Smaller economies populated by over generations of households of age 1 to up to 100. So people live up to 100 years. Okay. So there are also business firms in government. Okay. There's a standard model. It says each household maximizes expected utility. This is the constraint is conventional consumption saving decision. This is income from return from a saving. This is income, labor income. This tax on labor income. This tax on its contribution rate, contribution on social security. So borrowing is not allowed in this setting. So I just take a purely target ivory time model. There are two different productivity arguments. First one is time varying labor productivity is X. H is age dependent productivity is changing. It's fixed. It's determined, but it's only varies over time, over age. So there are two different constraints. First one is only applies to households or working and not retired. The second one is just retirees. So they don't have any labor income, just transfer from income. It's social security, like pension. Business firms, I just assume a capitalist production function. This is exogenous growth of labor augmenting technology. So this is first the conditions. As it government was a constraint. G is government expenditures. D is government debt. R is interest rate, and T is tax revenue from taxes. So tax revenue should be equal to consumption tax and tax revenue from asset, tax revenue from labor income. So in equilibrium, total asset is equal to capital stock, and public debt. So we assume consumption tax rate and capital income tax rate are fixed. Just income tax rates are varying. It's policy variable because, as you know, if we choose consumption tax rate and capital income tax rate and labor income tax rate, infinitely many combinations, policy variables, and it's unlike the reality. So we have lots of funds for our pension, but we assume the pay-as-you-go pension system because the worse the better. I mean, the worse the system, the worse the economic environment, we can have. It's personally, I think it's better interpretation. Tax rate of the pension system is determined accordingly. So let me show the equilibrium condition of pension system. As I mentioned previous slide, economic growth is exogenous, so we have to transform the model economy like this. Just skip this slides. The same for business firms, the government, asset market equilibrium. This is definition of recursive equilibrium. This definition doesn't look at transitional dynamics, just a steady state. And our focus is on transitional dynamics for different fiscal rules. So the steady state is that the state the model economy eventually gets into. So we need to find time path for labor income tax and social security contribution rate, equilibrium wage rate for on this transitional dynamics, as well as the growth rate for aggregate output is GDP. Because households have to know the path of growth rate because they need to solve their optimization problem. Let's go back to the slide right here. It's growth rate, gamma, it's growth rate, it's gamma right here. So in equilibrium, they should be equalized. So its computation is not quite complicated, it just takes time. Third fiscal rule, like it takes a week. I mean, just run the program and just waiting for several days and it's done. Let's talk about quantitative analysis. So we need to calibrate the model parameters. So we assume households enter the economy at age 27 and retire at age 66. It's not quite realistic, but I take that as given. And live up to the maximum age of 100. So conditional survival probability, the steady state is that comes from Statistics Korea. It's projections made by Statistics Korea. This is population distribution over age. So calibrate from the Statistics Korea. Time varying labor productivity that comes from Sunbin Kim and Yong Sung-jang 2008. This number is not from this paper. They estimate, I think, 0.34 something greater than 0.3, but we introduce age-specific labor productivity. So I set this number a little bit lower than Sunbin Kim and Yong Sung-jang. And we also introduce age-specific labor productivity, that's H. This is deterministic, but this is stochastic over a life cycle. The other calibration is conventional, but the capital income tax rate is fixed, and consumption tax rate is also fixed. So about 29%. This comes from OECD 2009. Consumption tax rate is 5.4%. Is a real effective measure. In a benchmark rule, it's constant debt to GDP ratio. We set constant debt to GDP ratio is 36%, and government expenditures to GDP ratio is 28.7%. This is a steady state, as well as a constant debt rule, the benchmark rule. Interest rate is fixed on 2.3%. TFP growth rate in the long run is 2.2%. Pension the ratio to GDP is 40%. So other thing is conventional, and one feature of our model is that we assume each household has an endowment of an asset, like 8% of average asset of age 49 is calibrated from the Survey of Household Finance in Korea 2006. Parameters in a steady state determined like this. So it's amazing. If you look at the live income tax in the steady state, 34% is more than 30% is your labor income tax rate. Because it's only a variable tax rate in the long run. And social security tax rate, contribution rate is almost 20%. This is it's not quite realistic, but it's meaningful. On the transitional dynamics, we just calibrate the conditional survival rate from Statistics Korea like this. Let's get this, and The number of new entrants in each year are computed mimic the population projections made by Statistics Korea. The formula is this. Pattern looks like this. And on the transition dynamics, we just look at the transition dynamic. I'm sorry, the period of the transition dynamics. We assume 2010 to it's more than 2050. But in this period, we assume exogenous government expenditure given by National Assembly Budget Office. 2010 is about 22% of GDP and keep rising up to 28% in 2050 and then keep constant. Growth rate. So actually, we can calibrate the rate of TFP growth rate because nobody knows the path. So we use Jinny Han et al. 2007. Actually, they make some projections of the growth rate, TFP growth rate, and GDP growth rate. We just use GDP growth rate and then recover TFP growth rate from our model. So the green dotted line is from, I'm sorry, a red one is from Jinny Han's projections. That's a GDP growth rate. We assume the blue line, that's a TFP growth rate, labor augmenting technological progress. We assume this path, so we get the green dotted line. So it's just mimic Jinny Han's projections. It's not quite different, but not quite the same. But it's and then finally, we also take the exogenous path of interest rate from Jinny Han 2007. So this is the result under a benchmark rule. Okay, so I think I have 3 minutes. The normalized 1 in 2010. So if you look at the labor, that's the efficiency unit that's kept falling over this period, and then we have even though the labor keeps falling, capital stock and output keep rising. This is a GDP growth rate. If you look at the blue line, 2010 GDP growth rate 5% is amazing, but it's just calibration. But it just if I plug a lower TFP growth rate into the model, we get just a shift down the path. So just don't worry about this number. Okay, so kept falling during 2010 to 2050, and then this is bounced up because the economy is moving back to the steady state. I mean, it's because due to the force of adjusting right after transition dynamics. The red dotted line is growth rate for capital GDP is higher than GDP growth rate because low population, the smaller size of the population. So income tax rate. I was showing you the steady state level of labor income tax and social security contribution rate, but on the traditional dynamics is labor income tax rate almost 60%. Social security benefit contribution rate is about 40%, even though steady state is 40% and 20%. The traditional dynamics population effect is really huge. The second rule is balanced budget rule. Under this rule, as you know, this term, the last term should be 0 each point of the time. So if the economy is growing, so gamma is positive, the amount of debt is shrinking over time. But this is a difference in income tax rate. We just subtract income tax rate under balanced budget rule from tax rate from benchmark rule. So if graph is right here, that means tax rate is higher under the balanced budget rule. This is obvious. But after 2030, tax rate is lower under balanced budget rule than under benchmark rule because the size of that is shrinking. So there are feedbacks between output and distortionary income tax. So the blue line is GDP, red line is cumulative per capita GDP. Just accumulate the per capita GDP. We didn't discount. We didn't apply any discounting factor. Discount factor just add up per capita GDP in each year. So this is positive means benchmark rule is better in terms of cumulative per capita GDP or GDP. But in this area, which means balanced budget rule will be better in terms of these two aggregate measures. So if you look at cumulative per capita GDP, it's negative, which means balanced budget rule gives us a bigger size of per capita GDP. I mean, in terms of a cumulative measure. We also compute the average weighted average of households spontaneous utility. Just calculate temporaneous utility and then add up by applying different weights for different households. So this area implies the benchmark rule will be better. Up to 2090, benchmark rule will be better. 2.5. Actually, we convert this number 2.5% utility. It's almost like consumption unit is quite minor. So we just robust checks. We assume there are government transfer from across households. The results are not quite sensitive to this changes in policies. TP growth rate. Some argue TP growth rate is too high, so we just adjust that to around 2% for entire period. Results are not quite sensitive to these changes in TP growth rates. Interest rate could be endogenous, not fixed, not determined exogenously. So we just look at endogenous interest rate. The result is striking. I mean, so this is interest rate. If you look at this exogenous interest rate case, but if you look at red line or green line, is interest rate goes up to 7%. Capital stock decrease rapidly around this period. Final, the third rule is a 60% rule. The result much better than a balanced budget rule or constant end rule. But I want to show you this result. GDP. So the GDP is much better with a 6% rule, but after 2050 is it goes down. This goes down. It goes up. It goes down. 2050 because 2050 we assume constant net rule should be enforced after 2050. So this fluctuation, even though we don't have any aggregate shocks, so there's lots of fluctuation take place right here. So we don't think 60% rule is quite a good rule. I mean, in terms of in 2050, the fiscal rules will be replaced with the constant debt rule. So, let me conclude this paper. Our paper. When you have a fiscal rule such as debt rule or budget balance rule in place, the labor income tax rate will increase rapidly because output decrease is due to slow workforce growth and long-run economic growth. The contribution rate on the pension system will rise rapidly if the pay-as-you-go system is assumed. Compared to the benchmark model, debt rule, constant debt rule, the balanced budget model predicts that by 2050, the debt to GDP ratio falls from 36% to 15%. Difference in income tax rates of the two different fiscal rules shrinks around 2030, as I showed you. Implementing stringent fiscal rule, that's a balanced budget rule, before population aging intensifies, it reduce the fiscal burden because of a lower debt-to-GDP ratio, reduce distortions to labor supply by lowering the income tax rate, and induce people to work more. So we are likely to cling to balanced budget rule in this paper. Thank you very much.